On the Spot takes you behind the scenes of a routine flight.
From Montreal and Toronto. Regina passenger Oliver. Regina passenger Oliver. Please advance to the airline ticket counter.
Hello, I'm Mr. McElhager. On the spot for you watching this routine flight come in. A sight most of us have seen many times. Flight number 3 is just one of 10 transcontinental flights that touch down here every day, and just one of hundreds of daily arrivals at airports all across the country. You know, Canadians travel many millions of air miles every year, and most of them take flying pretty much for granted. They hop 1,000 miles in a few hours, safe and comfortable, and think nothing of it. They get on and off aircraft as they would a train or a bus, never stopping to wonder what makes scheduled flying possible. We're going to take a look backstage and see what's behind any routine flight. Also, we're going to see a new and exciting aircraft, and we're going to fly in it. We'll be the first North Americans to travel in this new airliner. Pretty full program for 30 minutes, so we'll hurry along. First stop, one of the best airline service centers in the world. Behind all flight is an elaborate system of operational and maintenance routine. Much too complex for us to go into in detail, but there's one aspect of maintenance I think you should be interested in. That's the care of the engines which make flight possible. This is TCA's engine shop, and there's a man over here I think we should talk to. Hi, Mr. Pitlick. I was hoping I'd run into you.
Hi, still touring the place?
Well, this is the grand tour.
So I see.
This is George Pitlick, superintendent of maintenance and overhaul. You know, everywhere I've been in the shop, I've run into expressions like record system, safety limits. What do these things mean?
Come with me, and I'll show you.
Thanks.
Here's a Merlin engine being dismantled. In our files here and in Montreal, we have a complete record of this engine. Here in our shop, we also have detailed records of every major part. All these parts and the engine as a whole have a safety limit or service life. You know, so many hours of operation. Actually, our limit is way under the real limit.
Well, how do you know what these limits are?
Through research and experience. Now, from our records, we know exactly when to remove an engine from its aircraft. As soon as its safety limit or service life has been reached, out it comes and it's tagged for overhaul. Unserviceable. This engine may have been running perfectly, but it's unserviceable as far as we are concerned.
And I've seen these tags on parts, too.
Yes, parts, when they reach their service limit, are removed and repaired or replaced. But we don't depend entirely on service limits. Here, come with me, I'll show you something.
Say, I haven't seen this gadget before.
That's the Carboblast cleaner. It uses walnut shell.
Uses what?
Walnut shell. We wash all parts in special solvents and then blast them clean with fragments of walnut shell. Sand can scratch and score metal, but these shell pellets clean without damage. Got a defective part there, Charlie?
Yeah, I think so.
I said that we didn't depend on our records alone. This part, which is a reduction gear housing, has been condemned, even though it looks okay. It wasn't due for replacement according to our records, but every part is checked by a special black light process.
What's that?
After cleaning, the part is coated with a special substance. Then we take this light and shine it on the part. See what we found here. See that white line on the metal? That's a crack. All the rest is almost black. Fluorescent particles catch in any crack, and they shine only in the black light. When I remove the lamp, no crack.
Yes, you're right. Can't see a thing there. But after all, you could have used a microscope.
Well, yes, but this is quicker and more efficient.
Well, do you use many scientific tests and gadgets?
All the proven ones. In our engine work, though, we depend an awful lot on human judgment and experience. These aids that we provide to our specialists permit them to do a better job.
So you have your case histories, and inspectors, and gadgets. Seems like a pretty elaborate procedure.
Well, the engine is the power center of the aircraft, and we must turn them out as near perfect as possible. That's what we try to do in our shop.
Well, we know you're a busy man, Mr. Pitlick, so we'll just wander along on our own. Thanks a lot.
Quite welcome.
After the black light test has weeded out defects, inspectors check on safety limits and look for signs of wear. Here a supercharger shaft is discarded. Many parts, such as valves, are repaired by precision machine work. Larger parts, like engines, are machined with special apparatus. Here the valve seats are being reground. I thought for a minute this one had started up.
Oh, no, an engine out in the test house back here.
Oh, I see.
Yes, we test each one of these engines at least 4 hours.
And this one's all finished, eh?
Yes, it's all ready to go back to work.
Serviceable. This is a word used a lot around here. You'll find the same thorough procedure in all the shops. Radio, instruments, propeller, airframe, and so on. All very important and interesting places, and it's too bad we haven't got time to see them all. But we have to get along to operations. This is one of the weather offices maintained at major airports by the Department of Transport. Here, pilots are briefed in detail on weather conditions along their course.
This low is bringing moist air into eastern Canada. However, for your flight, let us consider the west. Across the prairies, there is very little. There is no icing, and only a broken cloud over Regina, Medicine Hat, and Calgary at 14,000 feet.
Well, what's the situation across the mountains at 14,000 feet, Oz?
It should be very good. You have a broken cumulus cloud, which is based around 9 to 10,000, topped at 13. So that you'll be flying in no cloud, no icing, and only light headwinds.
Okay, that's fine.
Every flight is carefully planned. Weight of cargo and passengers, weather, wind, fuel load, and so on. The office makes an estimate of all these factors, and so do the pilot and the co-pilot. They compare estimates and arrive at a final one.
Think this fuel load is okay, Mel?
Yeah, okay to Regina now. What about the headwinds over the mountains now? Oh, we can get a further check before leaving Calgary. Fine, I think it's okay. Okay.
Here, every flight is flown on paper. Every detail checked and rechecked before an aircraft leaves the ground. And this pre-planning is communicated to all points concerned.
Number 3 compartment is Air Express. We're planning the normal crew change here at Vancouver. Flight 3 is being cleared with 1,200 gallons.
Okay, you planted on time, Montreal. We'll assume that the flight will depart in 20 minutes. Okay.
For less urgent communications, Operations has a teletype network which links the entire system. Radio, of course, is used for direct contact with aircraft in flight.
Flight 4 from Winnipeg.
Winnipeg, Flight 4, go ahead.
Roger, Flight 4. Change for your load sheet. Total cargo should read 1,100 pounds. Gross takeoff 74,545. Go ahead.
Go ahead, the Winnipeg weather.
Winnipeg is 20,000 thin scattered, 15 miles. Go ahead.
Flight 4, check.
Finally, let's look in on the airport traffic comps up in the control tower.
Navigation 2301. Radio check. Time.
All aircraft traffic in the air, over and near the airport, and on the ground is controlled in the tower. Landings and takeoffs are coordinated. Weather and wind are judged, and runways are selected. Mr. Harvey, how's traffic today?
Very good, thanks. About average.
What is your average here?
Well, counting the airlines, the Air Force, and the private operators, about 500 landings and takeoffs a day.
Well, you've just got news service going through, haven't you? Something that goes practically over the pole?
Scandinavian Air Services now operate 2 flights each way per week here, and they get closer to the North Pole than anyone has got before.
I'll tell you, we're very interested in the Viscount. Have you had a flight plan on it yet today?
Yes, I just copied one here, taking off in about 5 minutes. Is this the one?
That's us, a special on-the-spot premiere. We're going to be the first passengers to fly in TCA's new turbojet airliner, the Viscount. See you in the hangar. You've probably already seen the Viscount in the newsreels. It's a very fine aircraft. It's not big in size compared to some, but it does carry 40 passengers, and it cruises at 320 miles an hour. That means it can make Winnipeg to Toronto in just about 4 hours. TCA will eventually have 22 Viscounts in service, and they'll be the first turbojet airliners to operate in North America. Hi there. Is our plane ready to take off yet?
Not quite.
Oh, this is Jim McLean in charge of base maintenance. Say, you're not overhauling these new aircraft already, are you?
No, we're finalizing our maintenance procedures. The men you see here are on training. We bring our mechanics, licensed mechanics, and crew chiefs in from the various points in the system where the Viscount will eventually operate and train them right here.
But will you have a central overhaul set up?
Yes, we'll handle the Viscount as we do the DC-3. Complete overhaul.
You know, this catwalk arrangement intrigues me.
Well, it's what we call a maintenance dock. It's a series of fixed and movable stands designed and built right here in our own shops to maintain the Viscount. It's to make the work easier and more efficient. Would you like to come around and have a look at the other side?
Fine. This is a turbojet engine.
Yes, we call it a propeller turbine. It's a Rolls-Royce product, like the Merlin. It's called a Dart. Very appropriate name, because it's very simple but powerful. You'd like to see one taken apart. I think there's a training class going on right now.
This is a Dart combustion chamber, and it is connected between your compressor outlet elbows and your discharge nozzles in your turbine section right here. It transfers high compressed air from through your combustion chamber to your turbine. The engine during start is lit up by number 3 and number 7 combustion chambers by a surface discharge plug. The flame is then transferred to each combustion chamber by interconnectors and then transferred by high pressure through the combustion chamber to the discharge nozzles at the turbine section.
Well, now you know how the Dart works.
Not quite.
Well, come with me. We'll fix that. This is one of our demonstration rooms. Here's a cutaway of the combustion chamber, and this is the injector nozzle the instructor was telling us about, right here.
Well, this looks about the same size as the real thing.
It is. These aren't models. These are actual parts. Let's take a look at the Dart diagram. Here's the combustion chamber in relation to the rest of the engine. The fuel, which is roughly a mixture of gasoline and kerosene, is ignited in this chamber and keeps burning steadily. Air is forced through the chamber, is heated by the flame, expands, passes through the turbine out to atmosphere. The shaft that carries the turbine at one end has the propeller at the other, and that's all there is to it. Here are the engine parts here. This is the turbine, and the combustion chambers, 7 of them, are mounted in front of the turbine. And the air is heated, expanded, and increases in velocity down the combustion chamber and drives the turbine at very high speed.
Oh, and what are these gear things here?
These are the compressors. They compress the air to increase the mass airflow into the combustion chamber.
And what makes them run?
The same shaft drives the turbine, compressors, and propeller.
Everything seems to make everything else run in this engine. What about starting up? Do you use some sort of electric spark?
Yes, we use a conventional electric starter motor with 2 high-energy igniters to ignite the fuel.
And supposing a motor cuts in flight, what happens then?
Well, we simply relight it. We can show you how that works on our flight. It's a training and testing flight, so we can feather an engine or 2 for you.
Well, not all of them, I hope.
Oh, of course not. But actually, there's much less danger of an engine failure with a propeller turbine type of engine than with a reciprocating type, because it's less complicated.
I suppose this simplicity is one of the chief attractions for TCA.
Absolutely. And besides, it's easier on the engine, on the airplane, and on the passengers.
Why on the passengers?
Smoother flight, less noise, less vibration. Here, I think I can show you what I mean. It's not a very good illustration, but it may make the point. If I take this chain and key and apply power to it like this, see what happens? The movement is rough and jerky. If, however, I apply motion like this, see how smooth it is? This business where the pulsing power is applied to a shaft turning in this direction to move a piston operating like this is characteristic of all piston-type engines. That's the way they work. But the propeller turbine has none of this up and down, in and out motion. It just turns very smoothly.
I see.
Also, this engine develops more power for its size and weight than a piston-type engine. And one of the problems we face with the piston-type engine, not just TCA, but every airline in the world, is that we've taken just about as much power from it as we can, and it's reached the end of the road as far as further development is concerned. The propeller turbine, on the other hand, is just on the threshold of its eventual development.
Well, will the Viscount supersede TCA's other aircraft?
Oh, no, our North Stars and Super Constellations still have their job to do, but the Viscount will take over on the medium-range intercity runs where it can operate faster, more efficiently, and economically. Incidentally, the Viscount is a cheap airplane to maintain.
I'll be looking for cheaper fares in that case.
Well, that's not my department. Incidentally, it's about time for our flight. I'd suggest we moved along.
Fine.
Say, here's the thing in a nutshell. There's a Merlin engine. Good, sturdy piston-type engine. One of the best in the world. Next is a Dart. Look at the difference in size, yet they're almost equal in horsepower. Next is the turbo-compound engine from the Super Constellation. This is a good example of the complexity of a large piston-type engine compared to the Dart.
Looks like a midget alongside that big one. Next one of these, you see, will be hauling us through the air several thousand feet up.
are you enjoying it?
Very nice, very smooth, just as described.
That's the advantage of a propeller turbine. This instead of this.
Well, is the Viscount a long-range aircraft? I mean, can it carry enough fuel for long trips?
It has a good range, 1,000, 1,500 miles. After all, this aircraft flew here from Britain where it was built.
Well, there's not much noise from the engines in here. It's fairly quiet.
The noise level is quite good, and there's very little vibration.
Is this a brand new aircraft, the type, I mean, or is it in service elsewhere?
There are operators using the Viscount today in Europe, but we will be the first to introduce it into North America.
Say, is there any chance of a ride up front?
Yes, I spoke to the captain, and you'll be able to sit in the first officer's seat. He should be back in a moment.
I suppose they've all had a pretty intensive course of training.
Yes, they've spent a considerable amount of time over in England training. We've also had a number of maintenance personnel over there. The instructor you saw in the classroom was one of them.
Pretty big step when an airline adopts a new aircraft. I suppose, for example, you've had to change all your existing maintenance routine.
Well, not exactly change them, but they've had to be extended in order to include the Viscount. We're still operating our other types of aircraft and have full maintenance on them. Here comes the first officer now. Hello, Captain.
Hello, Jim.
Captain Payton, Liston McElhaga.
Hello, Liston.
Howdy do.
Enjoying the flight?
Very much indeed, thanks.
Grand. Well, Captain Hubbs is waiting for you up front.
Oh, good. I'll go right along then. Thanks.
Hi there, Captain.
Hi there. How are you today?
Very fine, and thank you for having us along in the Viscount today.
Not at all. Very pleased to have you come and visit. I guess there's not too much room up there for your on-the-spot camera, but I hope you can get along all right.
Well, after all, the cockpit was built for a pilot and a co-pilot and not for cameras. But tell me now, you've already checked out in Viscounts. Why are you doing so much flying?
Well, this particular flight actually constitutes an indoctrination for some of our instructors who will be responsible for training our regular line captains.
What do you do on these flights besides just, well, fly?
Well, we undertake to demonstrate the handling characteristics of the airplane very thoroughly, and over and above that, to demonstrate the emergency procedures. Now, I understand that you were interested in the feathering and the relight procedure.
Yes, that's right.
Well, I can very quickly run through it if you would like.
Please.
Well, we'll simply shut down the number 1 engine in this manner here. And now it's feathered. And now we'll cut number 2 engine.
Doesn't seem to make any difference.
No, as a matter of fact, and we can maintain altitude on 2 engines with a full load. Actually, any 4-engine airplane can. That's the advantage of the 4-engine aircraft.
I understand it's very simple to start these engines up again.
Yes, indeed. We can just go through the relight procedure, if you like, first of all on number 2. Now, number 1. Well, that's about it. Now, is there anything else I can do for you or show you?
Well, not at the moment. I wanted to ask you, how is the Viscount to fly generally?
Oh, it's a very, very pleasant airplane to fly indeed. Very pleasant.
Well, is there any part of it that's particularly attractive to a pilot?
Oh, no, it's very easy in all respects. The handling is very straightforward and simple, and everything is very much to hand in the cockpit, as you can see.
Well, I think that's about all, then. Thanks very much for the demonstration.
Oh, you're perfectly welcome. And I wonder if you would mind calling Tommy to come back up so that then we can carry on with our training.
Will do. Thanks very much.
Fine, thank you.
Well, that was great. But you know, there's one thing that puzzles me, and that is, these are jet engines. Why use propellers?
Well, to move an airplane, you have to have thrust. And you can get this thrust from propellers like these, or, as in the case of a pure jet, from the jet stream. Now, at the speeds that today's airliners operate, the propeller is more efficient.
Yes, but isn't the pure jet faster?
True, but it's a matter of economy. The pure jet has its place in long-range, high-altitude flights, but you have to fly the pure jet very high in order to cut down on fuel consumptions. The propeller turbine, on the other hand, can operate in the medium altitude range with a reasonable fuel flow.
Well, we'll come to the jet airliner in time, though, won't we?
Yes, but the propeller turbine has definite advantages today and probably will have for some time.
Going lower.
Yes, I believe we're going into land. Better do up our belts. Just about to touch down.
How long before the Viscount comes and goes like that?
Oh, it won't be long now, but it takes a lot of preparation and planning to set up routine flights.
So we've seen. Well, that winds up this on-the-spot report. And this is Liston McElhaga saying goodbye from Winnipeg.
On the Spot is a production of the National Film Board. Routine Flight was produced by Gordon Burwash and Grant McLean. Location sound was by John Locke, the film editor Marion Meadows, and the narrator Liston McElhaga.